Today's video is all about the introduction of relativity. Discuss over the intro of the general theory of relativity, the special theory of relativity, usefulness of Newton's theory, the inconsistent of between the relativity and the quantum mechanics, the postulate of the special theory of relativity, and the ultimate speed of the universe. It was 1905 when Albert Einstein was 25 years old. And before the date of 1905, we actually not know who is he. He was popular by publishing 3 papers on the analysis of Brownian motion, second, the photoelectric effect, for which he won the Nobel Prize, and third is the special theory of relativity. After invention of special theory of relativity, he invent also the general theory of relativity. By using the words general, it actually says that it is a generalization form of special theory of relativity, and it say lots about thing and it's have everything. While we are going to discover what the relativity actually is, we actually inform that people think it very hard way that relativity is a hard topic. Yeah, actually it is a hard concept to grasp, because we can't see in real life that what was going on in the speed of light. If we travel in the speed of light, what is the time dilation, because it never connected to our real life. We never see that time is dilated for moving faster, because we never move so fast. Also not know about the length contradiction, so it is not related to our practical life and real life. And the mathematical expression of the relativity also seems to be hard, because there are lots of square root, transformation of coordination, and a constant like v square minus c square, and say lots about this, and it seems to be that it is really hard. Now discuss about the general theory of relativity at first. General theory of relativity, it suggests that the space-time curvature is not flat. It curves for the mass and energy. We actually state the terms also energy, because we know that the mass and energy are equivalent. If mass can curve the space-time, then energy also will curve the space-time. Here the inertial frame of reference are accelerating, so we call the non-inertial frame of reference. Throughout his life, Einstein wanted to find what is actually gravity is. This general theory of relativity say lots about the gravitational wave, about the universe which is expanding, and the black holes, why the times get slow in the strong gravitational field, and about the bending of light near the massive star-like sun. Now what the special theory of relativity says. It is all about the inertial frame of reference, and here the space-time curvature is flat. For the inertial frame of reference, the Newton's law of motion is valid here. Einstein's special theory of relativity is all about the inertial frame of reference, which actually states that the frame of reference is non-accelerating motion with respect to the observer, moves with the constant velocity or statistic. Newton's laws are valid in this inertial frame of reference. Einstein demonstrated that the space and time are entangled. That is, the time between two events depends on how far apart they occur, or vice versa. The entanglement is different from the observer, who have relative motion to each other. So time do not pass as fixed rate, because before the invention of the relativity, we know that the time is constant, and for everyone time passed in the same rate. But after the invention of relativity, we know that the time not pass at the same rate for every observer. It depends on the relative motion for each other, so the time don't pass as fixed rate. So we can say that relative motion can change the rate at which the time passes. So it is the main point of special theory of relativity. Now we know about what is the importance of Newtonian theory. Actually, Newton theory of gravity, which tells us the gravitational force between two bodies depends only on its mass and independence what it actually made of. So we not need to have a theory of structure and constitution of sun and other planet in order to calculate their orbit. So it is more easy, and this is the great advantage, that it is much simpler to work with than the Einstein theory. Two basic partial theory describe the whole universe. One is the general theory of relativity and second is the quantum mechanics. The general theory of relativity describes that the force of gravity on the large scale of the structure of universe, and on the other hand the quantum mechanics deal with extremely small scale. Unfortunately, we have to say that both two theories are known to be inconsistent to each other, because both cannot be correct in simultaneously. So deal with it, scientists create a theory which is called the quantum gravity. In quantum theory of gravity, we actually note that the gravity is described by the exchange of the virtual particle called the graviton, which has a zero rest mass and its velocity is almost near to the velocity of light. Okay, now we go to the fundamental postulate of theory of relativity was that the laws of physics should be same for all freely moving observer, no matter what their speed is. If we extend this idea to include the Maxwell theory and the speed, all the observers should measure the same speed of light, no matter how fast they are moving. So the special theory of relativity based on two postulates. One, the laws of physics are same for every inertial frame of reference. The inertial frame of reference actually must be straight. Okay. It is called also that the relativity postulate. Later, Einstein's second postulate is said that the speed of light in vacuum is same in all the inertial frame of reference and independent of the motion of the source. This also states that in nature an ultimate speed c same in all the direction and all the inertial frame of reference. For an example, let's think about that a spacecraft turns on a searchlight while moving at a certain velocity. Then our common sense misleads us that its velocity will be greater than 3 into 10 to the power 8 meter per second. But its velocity is always same, and that will be the velocity of light in vacuum, because we calculate velocity is equal to distance by time. But when the velocity of a spacecraft is comparable with the velocity of light, then we have to take account the distance as a contradiction of length and time as a time dilation. For to take this account, we have get the same velocity for every time. The speed of light in vacuum is the ultimate speed of universe, having the exact value of c is equal to 2.9979245 into 10 to the power 8 meter per second. This reference line of the velocity have a huge importance to shape our universe. It shapes our present, it shapes our future, and even the past.